Okay, so we got 4 questions we're going to start with today. And so in your groups right now, before we start, I want you to be able to answer these 4 questions. What is the difference between distance and displacement? Please give an example of each. Explain the difference between a speed and velocity. Explain how positive acceleration can affect motion. And then describe 3 ways to change the velocity of a moving car. Why don't you pause the video right now and answer those 4 questions in your group and kind of discuss those a little bit. Okay, so first off, remember the distance is how far we would travel. Displacement is how far we are from the starting point. And so an example, again, like we gave in the previous videos, would be like if I drive to Warner from my house in Aberdeen and back to my house. If I'm where I originally started, my displacement is 0, but the total distance I traveled is 20 miles. So that would be an example. Remember when we talk about explaining the difference between speed and velocity, speed is a scalar, velocity is a vector. So they both are meters per second. However, velocity has to have a direction attached to it. And they explain how the positive and negative acceleration can affect motion. Remember, when we have a positive acceleration, we're increasing our speed gradually over time. And when so our initial speed is actually slower than our final speed. But with a negative acceleration, we're slowing our motion down. That's going to be a negative number 2. And so our initial velocity is greater than our final velocity. And so remember, when we're talking about velocity and describe 3 ways that we can change it, like a moving car, you can turn because we're changing direction. So if you're going north and all of a sudden you veer off and you do a 180 and you're going south, you've changed your velocity. If you slow down, you're obviously changing your velocity as well. You could stop. You could speed up, would also be the examples of this. So those are all things, because remember, we're not just changing meters per second, but anytime that you change that direction, you're changing that too. Okay, so let's go into section 3. Section 3 is going to talk about motion and forces. We're going to talk about Newton's first law of motion. And so inertia, one of the coolest words I think in physics, inertia is something we're going to talk about. Inertia actually doesn't happen a lot because it's the resistance to change in motion. And we have all these other factors that we're going to kind of take out of the equation a little bit, which aren't realistic. But when we start talking about inertia, we have like things like friction, air resistance. These are all gravity. These are all outside forces that slow an object down and prevent it from maintaining its original speed. So it's actually slowing down. So we'll talk a little bit more about that. But we're going to talk about how inertia can actually occur if you were in like a perfect environment. However, Earth's surface, not perfect. So let's start with a force. A force is simply a push or a pull on an object. So like you take your textbook and you push it across your desk, you're going to see that move. And so that would be a push on that object. You can pull it back. It's pulling. Gravity's pulling you towards the surface of the earth. And we have pretty much 2 types. We have a balanced force and an unbalanced force. And a balanced force would be like somebody sitting in my chair right now, and 2 people with equal force are pushing on that person in opposite directions, and the person doesn't move. That would be an example of a balanced force. They're pushing at the same, so what they have is 2 forces are actually canceling out, and the force applied to the person is equal to 0. And so when we start to calculate that, force is equal to newtons, and force is mass times acceleration. So you can actually write that onto your equation sheets. Force is equal to mass times acceleration. And so if you have somebody pushing 5 newtons in to the left and somebody's pushing 5 newtons to the right, and the person in the chair is just standing there and not moving, their net force is 0 newtons. But in an unbalanced force, you have 2 people pushing in opposite directions. However, those 2 people pushing in the opposite directions are not pushing with the same amount of force. So if we have one person pushing to the left at 10 newtons, the other person is pushing to the right at 5 newtons, you're obviously going to move to the left with an overall total force acting on the person sitting in my chair with 5 newtons, because one is going to be a positive, the other one will be negative. So they actually will reduce, and it'll be only 5 newtons of force is going to be applied. You could have 2 people pushing on the same side of the chair. And so if we did that, that would also be an unbalanced force because it's an unequal force in the opposite direction. So if I had 2 people, they're both pushing at 5 newtons apiece, with a total of 10 newtons to the left. The person would move to the left because there's no opposition and there's nobody pushing in the opposite direction. And so that's the difference between a unbalanced and a balanced force. Again, you can put onto your equation sheet as well, force is equal to mass times acceleration. And net force is the combination of 2 forces. Again, net force is the combination of 2 forces acting on an object. And that brings us to inertia. What a fun word. Inertia is a tendency for an object to resist a change in motion. Again, like I said, on our surface, this is not realistic because we have things like gravity pulling us down at 9.8 meters per second squared. Please put gravity on your equation sheets. 9.8 meters per second squared. That's how the force is pulling you to the earth. And that's why when we put a ball, or your little cars when you did your lab the other day, if you put those at the top of your ramps, they would roll down and they would start to speed up. They're having the same acceleration because your acceleration is due to gravity, 9.8 meters per second squared. Now, with Newton's first law, it's saying that an object is going to move in the direction it was moving unless acted on by an outside force, which actually is unbalanced. So, a great example of this would be when you're in a car. If your car is moving 65 miles an hour, you are also moving at 65 miles an hour in that car. And if your car happens to hit, say, a wall going 65 miles an hour, you actually don't stop with your car because you're not attached to it unless you're wearing a seatbelt. And you would actually fly past the car. And this is one reason that we have seatbelts in cars. Inertia kind of explains what's going on. It's like having playing a game of pool. You have all of your pool balls set up. You have the one cue ball that you hit. It hits all the other balls and they change directions. If that crash did not occur, you would not see those other balls move. So we actually have to act on that. So that's Newton's first law of motion. This law is also known as the law of inertia because it is the tendency for it to move. When we start talking about this, remember safety and seatbelts are really important. And it's because we're trying to reduce that injury. We need to attach you to the car. So when the car stops, you would actually stop. Otherwise, you would just keep moving at the same rate. We also have put things like airbags in cars to help you to stop moving as well. Now, you are going to have some problems over inertia and acceleration. The equations for Newton's first law are going to be your acceleration equation. So remember, acceleration is your velocity final minus your velocity initial divided by time. And the label for this is meters per second. When we're finding newtons is equal to mass times acceleration. Now, it's going to throw something in there like weight. And you can write this equation down. Weight is equal to your mass times your acceleration due to gravity. So like on planet Earth, if you were given somebody's mass, you can multiply that times 9.8 meters per second squared and you can find out their weight because gravity is affecting them. Just remember, when we start talking about Newton's first law, we do have all these other things or forces that affect this constant motion. So inertia, the tendency to resist this change in motion, is going to be affected by things like air resistance for falling objects. We are going to see things like frictional forces, rolling friction, sliding friction. Those are all going to stop an object from moving, and gravity itself. So those are the three main ones. We talk about inertia. One of the fun things you can do, and I'd actually like you to do this as a demonstration in class or kind of a little experiment. You could take a piece of paper and you can crumple it up. Put it side by side with a textbook. Somebody hold it off the ground. And drop them. Before you drop it though, I want you to make a prediction. Which one is going to hit the ground first? The paper or the book? And you have to give an explanation why. So I want you to predict what you think is going to happen. Just remember, what force is pulling them to the ground, and will they have the same acceleration rate? It's a good question. Okay, you guys have some homework assignments. I hope you have a great weekend, and we will talk to you next week.